We are being recorded. All right, so Sarah has some questions on the quiz. All right, so, quiz number 6. All right, so this is a factoring problem. As soon as you see that there are 4 terms, you should be saying to yourself that you know you're going to be grouping. And then whenever you have 4 terms, I suggest instead of trying to start with 2 and 2, you should look for 3 and 1. And what I mean by 3 and 1 is look at these first 3 terms. I notice, let me use a different color, that the first term is a positive perfect square. The third term is a positive perfect square. Well, that's the first requirement for having a perfect square trinomial. So now I'm going to test to see if the middle term is what I need. So I take the square root of a squared, that's a. The square root of 1 is 1. When I multiply those together, I get 1a, but when I double that, so multiply by 2, I get 2a, which is exactly what my middle term is. So this is a perfect square trinomial, and if you know your patterns, you know that a perfect square trinomial factors into the square of a binomial. So I'm going to put my parentheses for a binomial and put the quantity squared. And then the way you get the binomial is just that first, the square root of that first term, the square root of the third term, exactly what I just did to test to see if this was a perfect square trinomial. And then the sign of the middle term. So a plus 1, the quantity squared. If you multiplied that out, you would get a squared plus 2a plus 1. Okay, but I still have this minus b squared. So you went from 4 terms down to 2 terms. Your goal is to have only 1 term in every factor completely factored. Well, this is now a difference of 2 perfect squares. And so that factors into, I'm going to switch back to my purple. That factors into, let me put my parentheses, the sum and the difference of their square roots. So the square root of a plus 1, the quantity squared, is a plus 1. And so that goes here and here. And then the square root of b squared is b. That goes here and here. And that is my final answer. I now have 1 term. These are both factors, and both factors are completely factored and completely simplified. Okay, that is number 6. All right. Okay, let's go on to the next page. All right, I see that Andrew is asking for number 8 from the quiz, so just to go in order, I'm going to do his question next. All right. Oh, they just asked you to state the restrictions. So there was a small little section in our homework where they gave us a fraction and they said state the restrictions for the domain, so that means for x, so that this would be defined. But we never want the denominator to equal 0 because dividing by 0 is considered undefined. So I'm going to take that x plus 1 and say it cannot equal 0. And then I'm going to solve for x. So that means x cannot equal, to get my 1 over, I have to subtract 1. So that is considered my restriction. Okay? Doesn't matter what the numerator is. There's no restrictions for numerators, but denominators cannot equal 0. So that's all they wanted, Andrew. All right. Let's see. Next is number 10. All right. Quiz 10. All right, so 4x squared y over x plus y, the quantity squared, and then that's being multiplied by, in the numerator, x plus y, the quantity cubed, and that's over 2xy squared. Okay, I'm going to switch to red and start crossing things out. This is already factored for you. Everything here is are factors. So let's start with the x plus y, the quantity squared, compared to the x plus y, the quantity cubed. So x plus y, the quantity squared, is 2 of those factors. So both of those are going to completely cancel out in the denominator. In the numerator, it will cancel out with 2 of those, leaving me with 1. So I'm just going to cross out the cube, and I'm just going to circle this quantity so I don't forget about it. Okay, sometimes you guys cross things out, and then the stuff that's not crossed out, you forget about it because you don't see it anymore. Okay, so the 4 and the 2, both of those are factors. So the 2 cancels completely, and 2 goes into 4 twice. So even though that 2 is very clear there, I'm still going to circle it so that I don't lose it or forget about it. All right, the x's, there's one x in the denominator. This x squared in the numerator, of course, means x times x. So those are both factors. So that x factor in the denominator cancels with just one of the two x's in the numerator. So I'm going to cross out the square, and I'm going to circle that x so I don't forget about it. All right, the y's, they're factors. So this y in the numerator cancels with one of the two y's that are being multiplied in the denominator. So I'm going to cross out the exponent and circle that y. Okay, let's look for what's still there in the numerator. There is a 2, there's an x, and then there's the quantity x plus y. And then in the denominator, there's just a y. And so this is my final answer. Okay. All right. Let's see, that was Sarah's question. All right, number 11. Quiz number 11. All right, more simplifying. So notice this whole front side of this quiz is just full of factoring. If you are going into tomorrow's test going, oh gosh, I don't really know how to factor, I'm just telling you, you're in deep, deep trouble. All right, so u minus w, the quantity squared, this is times 6w minus 6u, and then 3u plus 3w. Sorry, my cookies are breaking. Okay, I'm going to factor. I just want to change colors. Okay, so numerator of that first fraction, I see a difference of two perfect squares. It's going to factor into the sum and the difference of their square roots. That should be so easy because it's just a pattern. So the square root of u squared is u, square root of w squared is w, and so I get u plus w times u minus w. All right, the denominator is already factored, so of course you're not going to multiply that out. And if you wanted to, you could write u minus w times the quantity u minus w if you wanted to. All right, I notice that there's a common factor in the numerator of the second fraction, and I always want to look for a common factor first. And so I get 6, the quantity, w minus u. And then in the denominator of that second fraction, I see there's a 3 in common, and then I'm left with u minus w. Okay, so let's deal with u plus w first. Let me cross out with red. So u plus w cancels with u plus w, and I can do that in separate fractions because of this times sign right here in the middle. That means everything here, they're all factors. All right, the u minus w in this first fraction in the numerator cancels with one of the u minus w's in the denominator of that same first fraction. So I'm going to cross out that 2, and I'm going to circle this so I know that it's still there. Okay, in the second fraction, do you guys agree 3 and 6 are factors? 3 goes into there once, 3 goes into 6 twice. I'm going to circle that so I don't forget it. Okay, I'm just going to write what I have left right now. Clean this up, and then we still need to talk because I'm not done. All right, that's what's left. Everything else is canceled out. So I have 2, the quantity w minus u, all over u minus w. Well, look at the w in the numerator compared to the w in the denominator. It's positive in the numerator, negative in the denominator. Comparing the u's, the u is negative in the numerator and positive in the denominator. So these two factors, w minus u and u minus w, they are opposites. So let me just do a little example here in blue up at the very top right. If I have 3 divided by negative 3, do you agree those are opposites? Well, that equals negative 1. If I have negative 5 divided by positive 5, those are opposites, and don't I get negative 1? So whenever you have opposites, they simplify and you get negative 1. So I'm going to cross those out, and I'm going to put the negative sign in front of my 2. So my final answer is negative 2. Okay? All right, that was number 11. All right, number 16, and I see that Emma has a question from my page. Oh, and I also see that Victor is asking for 13. So let's do 13 next. After number 13, I think I'll switch over to Emma's question from the book, and then I'll go back to the quiz questions. Okay, let's see, 13 is still on this page. Alrighty, we have x cubed plus y cubed. I recognize a sum of two cubes. Denominator, x squared minus y squared. I see a difference of two squares. Oh, you know what? I messed up on number 13. Oops, I didn't notice that was the division sign. Okay, in the, I was kind of wondering why, like, not much canceled out. All right, so, yeah, I did not see that division sign. So for those of you in my class, I sent you the answer key, that bottom of the first page, number 13. My answer's wrong. So let's fix it right now. All right, I'm going to change that division sign in the middle to a multiplication sign. So right now I'm changing the order, or taking the reciprocal of that second fraction. So I've changed my division sign in between to a multiplication sign. You know what? I think I did the same thing on number 12. Maybe not. No, I didn't. I did divide by it that. Okay. Alrighty, so number 13, I'm changing the division sign to a multiplication sign. I'm taking the reciprocal of that second fraction. So I've put the denominator in the numerator, and now I'm writing the numerator in the denominator. That is plus 3xy, and then plus y squared. Okay, so we have a lot of factoring to do. Can you imagine this question on the test and you don't know how to factor? Good luck. Okay, sum of two cubes. You have to know this pattern. It is a binomial times a trinomial, and then we say sing the song. So it's not really a song, it's just a little chant, I guess. All right, so you take the cube root of the first and the cube root of the second, and you keep the same sign. Then, now look at this x plus y, that's my binomial. I'm working with this. So I square the first, that gives me x squared. I change the sign. I multiply together, so that's xy, and then I add the square of the last. Okay? So a little bit faster, you take the cube root of the first and the cube root of the second, keep the same sign. Then square the first, change the sign, multiply together, add the square of the last. So there you go. Okay, denominator of that first fraction, I see a difference of two perfect squares. So that's going to factor into the sum and the difference of their square roots. You get x plus y times x minus y. All right, numerator of the second fraction, I see a difference of two perfect squares. Let me switch to red, and just above that x to the fourth minus y to the fourth, I'm going to do the first factorization. So it's the sum and the difference of their square roots. So you get x squared plus y squared, and then x squared minus y squared. So now I switch back to blue and show you that when I come from here down from that red, my x squared plus y squared, you cannot factor that, that's prime. But then the x squared minus y squared, well, that's another difference of two perfect squares. So I'm going to get the sum and the difference of their square roots. So I get x plus y times the quantity x minus y. Okay, and finally, excuse me, I have a general trinomial in the denominator of the second fraction. So I know I have to have a 2x and an x, and then I know I have to have a y and a y, so there's really not a whole lot of choices going on here. And because the signs are both positive and I have that 3 in the middle, I'm going to put a plus sign here and a plus sign here, and then I'm going to double check. So 2x times x is 2x squared. That's good. For my outers, I get 2xy. Inners, I get plus 1xy, so that combines to give me plus 3xy, and then finally plus y squared. Okay, we're good to go. Everything's factored. Let's switch to red, and let's start crossing out. Okay, I see an x plus y and an x plus y. Those cancel. Let's see. I see another x plus y and an x plus y. Those cancel. Oh, I see an x minus y with an x minus y. And I think we are done. Okay, so I don't necessarily mind if you put the trinomial first, but I'm going to put this binomial first, then this trinomial. No big deal if you put the trinomial first. But if you do have any monomials, I would like you to put those in the front. Okay, and then divided by 2x plus y. And you can either put parentheses around those, or you don't have to. Okay, so yeah, that's not the answer I have because I didn't realize that that was a division sign. Okay, so there's the correct answer. Okay, all right. Let's take a little pause from the quiz. I've done quite a few of them already. Matt, I am going to answer your question about absolute value. All right, but let me take a break for just a second and get to Emma's question about, let's see, page 94, number 139. Okay. All right, the directions here, Emma, say to reduce the radical index and remove any factors possible from the radicand. All right, so we have a 15th root of 27, x to the 6th, y to the 12th. Okay, and so what I would suggest doing is just take everything that's inside your radical sign and put that in parentheses, and then we're going to talk about the exponent. So what I'm trying to do is change this from radical form to exponential form. Okay, but first for the stuff inside my radical. 27 I recognize as 3 cubed, so I'm going to write it like that. And then x to the 6th obviously is already in exponential form, and same for the y to the 12th. Okay, so see what I did to my 27, I changed it to 3 cubed. All right, now if we were together in class, I would be asking you, what does the 15th root of change into if you're writing it as an exponent? And so it would be 1 over 15 for the exponent. Okay, so raising it to the 1/15th power. Notice the denominator, 15, that's your radical index. So now I'm going the other way. All right, and then we have a property of exponents that applies here, because when I'm raising a power to a power, you keep the same base. So I'm going to keep this 3, and then you multiply the exponents. So that gives me 3/15. Then to raise x to the 6th to the 1/15th power, I keep the same base, and I multiply the exponents. And then for the y, I keep the same base, and I multiply the exponents. Okay, so I'm just applying that 1/15th power to each of my factors. And you have to know the property that you multiply the exponents. All right, well, every single one of those fractions can be simplified. Okay, this becomes 3 to the 1/5. This becomes x to the 2/5. I simplified each of those by 3. So 3 goes into 6 twice, and 3 goes into 15 5 times. And then I get y to the, and then 3 goes into those also. So 4/5 power. So notice that every single fractional exponent has, for the denominator, a 5. Circling those. So I want to bring it back to radical form because they asked me to simplify or reduce the radical index. So my new radical index is 5. See how it's lower than 15? So I reduced it. And then what's left is a 3, an x squared, and a y to the 4th. And that's my final answer. Okay? All right, that was Emma's question. All right, I hope that was helpful. Okay, let's do number 97 from the book while I'm on the book. All right, so page, whoops, I said that wrong. It is page 93, number 97. All right. All right, here's the original problem. It says 25x squared minus 9y squared divided by, and then we have 2 terms, 1 plus 3y over 5x. Okay, so there are a few ways you can go about simplifying this. I'm going to write this as a fraction. That's what this division sign means in between, is the same as a fraction sign that means divided by. So first I'm going to factor this first quantity. So I have the difference of two perfect squares. That means it's going to factor into the sum and the difference of their square roots. So I get 5x and I get 3y. And so it's 5x plus 3y, 5x minus 3y. All right, then in the denominator, I'm going to go ahead and write this like this. 1 plus 3y over 5x. And so don't you agree that I have a little fraction within my whole big fraction? And so I'm going to do a technique that when we get into more complex fractions like this technique is so much easier than the alternative, which would be combine the 1 and the second term, 3y over 5x, into one fraction, and then say dividing by that fraction is the same as multiplying by the reciprocal. There's nothing wrong with that. Just watch how easy this is, though. I'm going to multiply by 5x over 5x. Okay, and I got that from this denominator. I call it the minor denominator. Okay, in the numerator, there's no distributing necessary. I'm going to write 5x, that's my red 5x, and then times the quantity 5x plus 3y times the quantity 5x minus 3y. So there's my numerator. Okay, now for my denominator, since there are terms, I have to distribute the 5x to the first term and to the second term. So for the first term, when I multiply the 1 times 5x, I get 5x, then I have a plus sign. And then when I multiply 5x times that fraction, doesn't the 5x cancel with the 5x? That was the whole point of doing that. So I get plus 3y. And then I notice that my numerator has a 5x plus 3y. That's going to cancel with that 5x plus 3y. And so my final answer is 5x. I'm going to write that first because it's a monomial. And then times the quantity 5x minus 3y. And that is my final answer. Okay, there you go. All right, let's answer Matt's question. Okay, just kind of a generic one. Can we go over a general absolute value problem? All right, so I presume, Matt, that you're discussing the absolute value rule. Is there one of those on this quiz? There it is. Okay, if you look at 14 and 15 on the quiz, and I'm curious if any of those questions were asked. Nope. Not from Sarah anyway. No, nobody asked any. Okay, well, you have to know this property. All right, so on the quiz number 14 and 15, let me just read these directions to you. It says variables may have negative values, so use absolute values as necessary. So it's very clear that you need to know the absolute value rule. Okay, so basically the absolute values rule says this. If you have the nth root of x to the n, sometimes you get x, but other times the nth root of x to the n gives you the absolute value of x, and you absolutely have to know when each of these is true. For the first one where you just get x, that is true if n is odd. And for the second one where you get the absolute value of x, that is true if n is even. So the way I like to remember this is the number 2 is even, and doesn't it take, let me do this in red, 2 symbols to make an absolute value sign? Okay, so I think to myself, oh yeah, 2 symbols to make an absolute value sign. 2 is even. That's when I need the absolute values, is when my n is even. Okay, so in number 14, they give us the 4th root of a to the 8th, b to the 12th. All right, so since this 4 is even, I am going to put absolute value signs, and then we'll talk after. Okay, so I'm going to take the 4th root of a to the 8th. That gives me a squared. And then I'm going to take the 4th root of b to the 12th, and so that gives me b cubed. All right, so this answer is not wrong, but it can be simplified. And I'll explain with some words in just a moment. All right, do you agree that a squared could never be negative? It can be 0, it can be positive, but it can never be negative. Well, the only reason I need absolute value signs is in case it is negative. Well, a squared can't be negative. And so I'm going to take the a squared out of the absolute value signs. Now b cubed, that could be negative. If b is negative, then b cubed is also negative. And so taking out the absolute value signs changes that value. And so the b cubed needs to stay in the absolute value signs. And so this is my final answer. And let me explain it with this little phrase. If you can remember this, even, odd. This is when you should have absolute value signs. Okay, so let's do this 4 for the radicand, I mean. Radical index, sorry, 4 is my radical index. That's even. That's this first word, even. Okay, I want to do the b to the 12th next. B to the 12th, well, that exponent is also even. So my 4 compared to my 12, that's even. And then when you take the 4th root of b to the 12th, don't you get b cubed? Well, that's my odd. So 4 to 12 to 3, that's even, odd. And that means you must have absolute value. So when you see an even, odd, I'm going to write must have absolute value. Okay, so around the b cubed, I do have absolute values, right? Right there. Okay, then let's look at the a's. I have 4, that's even. I have 8, that's even. But when you take the 4th root of a to the 8th, you get a squared. Well, that's even. It is not even, odd. That means no parentheses. And so notice we took out the a squared out of the parentheses. That's because something to an even power will never be negative. Okay? All right, so this boxed answer is the correct final answer for number 14. All right, let's go to number 15. This one seems so easy, but if you don't know your property and you go put the absolute values, you're going to end up getting it wrong. Okay, so it says cube root of x minus y, the quantity cubed. Okay, so bottom line, even though they said use absolute values when necessary, that index, radical index, is odd. That means there are no absolute values. So x minus y is the cube root of x minus y, the quantity cubed, and no absolute values. And that's it. Okay, so Matt, I hope that was helpful. All right, back to the quiz. Let's see. I don't remember what I went up to. 16 or 18? We did 2 book problems. Okay, 13 was my last quiz one. Oh, and before that was 11, yeah. Okay, so we're on to 16. Okay, quiz number 16. Okay, 16 gives us 27 in parentheses raised to the negative 1/3 power. So a negative exponent means 1 over this 27 to the positive 1/3 power. And if you think about what we did with negative exponents when we had a factor in the numerator of a fraction, then we moved it to the denominator and made the exponent positive. Well, that's exactly what I just did right here. So other words for this negative exponent right here, because it's part of an exponent, is either 1 over ... Well, that's exactly what I just did. I went 1 over 27 to the positive 1/3 power. But 1 over means the exact same thing as the reciprocal of ... Okay, and both of those will work. Okay, so 1 over 27 to the 1/3 power, well, that means the cube root of 27. Well, 27 is a perfect cube, so I take the cube root of it, I get 3, and there's my answer is 1/3. If I put 3, by the way, I would be wrong. Okay, so be careful about that. All right, so 1/3 is my final answer. Okay, that was 16. Let's see, number 18 is next. Quiz number 18. All right, we've got parentheses, a to the 2/3 power times b to the 3/4 power, and then all of that is to the 12th power. Okay, so bottom line, you have to know your properties. Since these are factors, when you raise a power to a power, you keep the same base and you multiply the exponents. Okay, so if you need to go off to the side and say, let's see, what is 2/3 times 12? Then first of all, I would recommend that you write it the way I just did here in the upper right-hand corner, so you can tell that your 12 is a numerator. So doesn't 3 go into there once, and 3 goes into 12 4 times. Okay, so that's what it cancels to, and so I have 2 times 4 is 8. All right, then I keep the same base, b, and then this time I want to multiply 3/4 times 12. Well, 4 goes into 12 3 times. 3 times 3 is 9, and there is my answer. Okay, there you go. All right, that was 18. Number 19. All right, we have x to the 3/5 times the quantity x to the 2/5 plus x to the negative 3/5. Okay, so this is a great example to show you that you have got to know your properties, and I think the words are very important. So when I say I'm going to distribute that x to the 3/5, do you agree that means I'm going to multiply it by each term? And so, sorry, if I'm multiplying those first two terms, the very first thing that should come to mind to you is, oh, I'm multiplying like bases. So you keep the same base and you add the exponents. I'm just going to write what that looks like. It should make this super easy. Okay, then I see a plus sign, and what's going on over here has nothing to do with what I just did. Okay, but I'm distributing, separate term, okay, so distributing, and I am again multiplying like bases. So you keep the same base and you add the exponents. So I get x to the 3/5 plus negative 3/5, right? I'm adding those exponents. Okay, so I know we're going a little back and forth, but back to the first term, I have x raised to the 3/5 plus 2/5. Well, those already have a common denominator, so that's equivalent to 5/5, which equals x to the first. Okay, second term, I have x raised to the 3/5 plus negative 3/5. Well, those cancel each other out, and I just get 0. So what is anything to the 0 power? It's the number 1, the whole thing. And then here I have x to the first, so I'm not going to write the first power. And there's my answer. Okay, that was number 19. All right, number 25. Okay, this problem has 3 divided by 2 the square root of 5 minus the square root of 2. All right, to get rid of radicals in the denominator, when there's more than one term, we have to multiply by the conjugate. So plus the square root of 2. All right, and whatever I multiply the denominator by, I have to multiply the numerator by the same thing. So there you go. Very tempting to distribute that 3, leave it alone. Okay, as a matter of fact, I'm going to write 3 the quantity, 2 the square root of 5 plus the square root of 2. All right, in the denominator, I'm going to multiply the 2 times 2, that's 4. The rad 5 times rad 5 is 5, so 4 times 5 is 20. Okay, for my outers compared to my inners, do you guys agree? Every time I do this type of problem, those are going to cancel. Okay, for the outers, I get a positive 2 rad 10. For the inners, I get a negative 2 rad 10. Yeah, and so those are just going to cancel out. That always happens with conjugates. Okay, let me switch this to red. When I go to do these lasts, invariably students will mess up the signs. So let's make it a separate step. A negative times a positive is negative, and then rad 2 times rad 2 is 2. So my denominator becomes 18, and I hope you see that the 3 and the 18 can cancel, simplify. You would have lost your 3 if you distributed it into the other two terms. Okay, so it's great that I left it factored like this. So 3 goes into there once, and 3 goes into there 6 times. And so here is my final answer. 2 square root of 5 plus the square root of 2 all over 6. Okay. All right, and that was number 25. Okay. How are we doing on time? 8:07. Okay, so from 25, I'm going to number 31, 32, and that's on page 3. Okay, it says -4 minus 2i divided by -2 plus I. Okay, so we want to get rid of the i's in the denominator. Since that has 2 terms, we need to multiply by the conjugate. So that's -2 minus I. Does everybody understand that conjugate is the same first number, same last number, but the sign in the middle is changed. All right, and if I'm going to multiply the denominator by that, then we should do both. Okay, I'm going to start with my denominator. My -2 times -2 is +4. Excuse me. Then, because these are conjugates, I know that my outers and inners are going to cancel. But just to kind of convince you, let's look at our signs first. I have a negative times a negative, so that's +2i. And then the inners, -2i. So they are obviously going to cancel. So then I just have my last step. The most common mistakes are made here. So what do I get from my sign? I get a minus sign. What do I get from my I times I? I get an I squared. So what is negative I squared? That's right, it's +1. So 4 plus 1, I have 5 in my denominator. Okay, numerator, the -4 times -2 is +8. Then let's do outers, inners, and then we'll do more. Okay, so I have the +8. Next, for my outers, I get +4i. For my inners, I get +4i. So that's plus 16i. Okay, next, I do the lasts. I'm just going to show this with a different color. Here we go. Sorry about that. Okay, so I'm going to show in kind of bluish purple. So first, the negative times the negative is positive. Then the coefficient is going to be 2, and then I have I squared. Let me double check. Plus 2i squared. All right, so that's going to turn into -2. And so my 8 minus 2 is 6 plus 16i all over 5. And so now all I need to do is change this to a plus bi form. My a, the real part of my answer, is 6/5. Then plus my b times I is going to be 16 over 5 times I. And that is my final answer in a plus bi form. Okay, I need to wake up a little bit here. Let's see, 8 to 10, we still have 20 minutes. All right, that was number 32 on the quiz. Okay, number 34. Let's see, it says 1 over I to the 15th power. Okay, I like to do it this way when the I is in the denominator, is think what is the number, the next number that's larger than, greater than, or equal to 15, that is a multiple of 4. Well, isn't 16 a multiple of 4, right? And we're already at 15. So all I have to do is multiply by I over itself. Okay, so that's so that my denominator is supposed to be a 1. When I multiply like bases, I keep the same base, excuse me, and add the exponents, so I get to the 16th power. Well, because 16 is a multiple of 4, I can just cross that out and say it's equal to 1. Now that seems kind of drastic, but we've talked about why that is the case. If I to the 4th equals 1, then I to the 16th being I to the 4th raised to the 4th power. Well, if I just have a 1 in here and I raise it to any power, actually, I'm always going to get 1. Okay, so that's why I can just cross out that denominator and say it equals 1. And then my numerator, I have 1 times I, so that's just I. So that is my final answer. Okay, so my answer is I. Okay, that was 34. Number 35. This is the problem that asks us to show, I'm going to write that word, show that 1 minus 2i is a 0 of this polynomial. Okay, so let's write down the polynomial first. So it's x squared. Oops, those are x's, not z's. We had z's. Oh, that's a mistake on that quiz. All right, I'm just going to leave them as z's. So it's z squared minus 2z plus 5. They gave you z equals 1 minus 2i. So it really should be in terms of z. Okay, so everywhere I see a z, I'm going to plug in 1 minus 2i. So first it needs to get squared, then negative 2 times 1 minus 2i, and finally plus 5. All right, so to help you out a little bit, I'm going to write 1 minus 2i times 1 minus 2i. So when I multiply across, I get 1. My outers and inners, I'm going to save some time. I know they're going to cancel because they are conjugates. And then the negative 2i times negative 2i, you multiply the signs and see what you're going to end up with. You're going to end up with a positive. You know what? I am not sure what I just said before that. I am multiplying this times this, and I think I went off track. Okay, my 1 times 1 is 1. My outers, I get negative 2i. My inners, I get negative 2i. And so combined, I get negative 4i. All right, and then for these lasts, first, I'm going to do this in 3 steps. I'm going to first look at my signs. I have a negative times a negative. That is positive. Then I have a 2 times 2. That is 4. And then I have an I times I, so that's I squared. I know many of you probably think that's a waste of time. I would suggest, highly suggest, you multiply that way for those 2 lasts, because so many mistakes are made on this one term. And that's all it takes is 1 mistake, and your whole problem's a mess. Okay, this 4i squared is equivalent to negative 4. Okay, all right, next I'm going to distribute this negative 2 right here and here. Okay, and so I'm going to get minus 2 plus 4i. And then finally plus 5, but I don't want to forget. Okay, I'm going to neatly underline my 4 i's. The first one is negative. That cancels with the second one. So those are gone. Okay, and then I'm just going to suggest, because from the very beginning we knew our answer was going to be 0. Oh, look, it worked. Okay, but you have to show it. So I'm going to suggest that we add up the positive constants. So 1 is positive and 5 is positive. So 1 plus 5 is 6. And then I combine the 2 negative terms. And so negative 4 minus 2 is minus 6. And that, of course, equals 0. And that's what I was trying to show, is that plugging in 1 minus 2i is a 0 of the polynomial, because it makes my polynomial equal 0. Okay. That was number 36. 36. Okay, so now I'm going to go back and do 35. All right, 35 says x to the negative 1 power minus y to the negative 2 power all over x to the negative 1 minus y to the negative 1. I imagine there are so many properties that some of you are thinking about using that actually do not apply, because these are terms, not factors. So you can't just say, oh, I'm just going to take that x to the negative 1 and put it in the denominator and change it to x to the positive 1. If it was a factor, you could do that, but it is not a factor. Okay, so x to the negative 1, just this term all by itself, means 1 over x. Okay, second, y to the negative 2, that means 1 over y squared. Okay. In the denominator, I have, oh, you know what? I think I copied it wrong. Yep, that numerator is x to the negative 2. Okay, so back to that first term, I have 1 over x squared minus 1 over y squared. Okay, denominator, I have 1 over x to the first, so I'm just going to write 1 over x. And then I have minus y to the negative 1 power, so that equals 1 over y. Okay, this is definitely a complex fraction. I'm going to simplify this the exact same way I showed you the other complex fraction. I'm going to multiply by the least common denominator of all 4 of those minor denominators. So the common denominator would be x squared, y squared. And I'm going to multiply that all the way through the first, all the way through the terms in the numerator, and then all the way through the 2 terms in the denominator. Okay, so when I distribute x squared, y squared to that first fraction, the x squares cancel completely, and I'm just left with y squared. Okay, then second term, the y squares cancels completely, and so I'm left with minus x squared. Okay. Oh, I just tried to fix that and I messed it up. That's a y squared. Use a different color. Blue. Okay, that was supposed to be a y squared. What a mess I've made. Okay, I'll fix it in a moment. All right, when I go to the denominator for the first fraction, 1 over x, when I multiply that by x squared, y squared, this x cancels with one of those x's, so I'm left with xy squared. Then my minus sign, and then the second term, I'm distributing that x squared, y squared to the 1 over y. This y cancels with one of these y's, so I'm left with x squared y. Okay, numerator of that fraction is a sum and difference of their square roots. So I get the sum and the difference, and then square root of y squared is y. Square root of x squared is x. And there you go. Now denominator, there's something in common. You always want to look for a common factor first among all the terms. Well, there's only 2 terms, but there's an x and a y in common. When I factor it out, I get y minus x left over. Okay, so y minus x cancels with y minus x, and my final answer is y plus x all over xy. Why don't those cancel? Because terms don't reduce. Okay, let's see. I have done all of Sarah's questions. Taylor, I think you've figured out that I had already done number 10. 8, I added to the quiz for Andrew. Emma, we did your page. 13, did I add? I think I did. Let me make sure. Yes, that's the one that I discovered I had a mistake on my answer key. All right, and then okay, Garrett is asking for factoring questions with 4 terms. All right, I want to go to our, let's see if there's some good ones here. Okay, here's a great one. This is on page 93. And what number is that? 82. All right, it says z cubed minus 4z squared minus 9z plus 36. Okay, so whenever there are 4 terms, I always tell my students, look for 3 terms that could possibly be a perfect square trinomial. So when I look at these last 3 terms, I know the signs might be a little bit off, but sometimes they just kind of work themselves out. Okay, here my 36, that third term, is a positive perfect square. My 4z squared, there's a minus sign in front of it, so it's not positive. However, I know that if the three terms are on the tail end of the polynomial, that we're going to factor out a negative. Well, if I were to do that, I would get z cubed minus and then a quantity. Okay, that quantity would be 4z squared plus 9z and then minus 36. Well, the first and the third terms have to be positive perfect squares, so that just totally messed it up. Okay, so since there aren't three terms that are a perfect square trinomial, and by the way, the middle coefficient can never be odd, because remember how we test that middle term? You take the square root of the first term, that would be 2z, multiply it by the square root of the third term, that would be 6, that multiplies out to 12z, and then when I double it, I would get 24z. Well, that's not even close to what I have there. Okay, so I'm going to switch the color, and I'm going to underline the first two terms and underline the second two terms. Okay, so I started off looking for 3. There were no 3 that would be a perfect square trinomial. So now I'm going to do it this way. Okay, first two terms, what's in common? There's a z squared. So then what are you left with? Z squared, the quantity, z minus 4. Well, that's all I can do. It's not factorable. I was thinking z squared minus 4, but it's not. It's just z minus 4. Okay, that's the first two terms. Next, I'm going to distribute, or factor rather, out of these two terms. So I'm going to write a plus sign and then a 9, the quantity, and don't I get z minus 4? So final answer, z minus 4 times the quantity z squared plus 9. I wonder if anybody would continue on and try to factor z squared plus 9. Nope, that's the sum of two squares. You're done. It is prime. And so that would be my final answer. Okay, let's see if there are any last minute questions. Yep, I did 97 already. Gianna, I don't think I did 101. Oh, you know what? It is so similar to, what's the other one that I did? Maybe it was from a problem from the book. Yeah, that's almost exactly the same problem, so I'm not going to redo that one, okay? All right, Taylor, on the test, will you tell us when we need to use the absolute value signs in our answers? I'm going to read it to you exactly like you're going to see, and it's from your quiz numbers 26 and 27. It's going to say, well, these directions say, reduce the radical index, and then in parentheses, oh, I'm sorry, I'm looking at the wrong one. Sorry about that. Oh, it is at the top of the page, but it's 14 and 15. So it says variables may have negative values, so use absolute values as necessary. Okay, same idea is going to be on the test. That means you guys need to read your directions. Okay, if they don't want you to use that absolute value rule, they'll just say, assume all variables represent positive real numbers. Then you go, okay, I don't need to worry about that rule. Okay, all right, Matt, you're welcome. Okay, Stephen is asking if I can show number 18 again. I'm not going to do it again because I already did. If you came in late, you certainly can go back and rewatch this. I'm just going to cursor back because I'm not going to do it again. I will go back and show you again. All right, so here's number 18. So a to the 2/3, b to the 3/4, that was in parentheses, and then all of that raised to the 12th power. So the property I'm using is when raising a power to a power, you keep the same base and you multiply the exponents. So my 2/3 times 12, I did over here in the upper right-hand corner. I went 2/3 times 12 because they're kind of far apart. My 3 goes into 12 4 times. 2 times 4 is 8. Okay, then b to the 3/4 raised to the 12th power. You keep the same base, b, and then you multiply the exponents. So I showed that over here as well. 3/4 times 12. My 4 goes into 12 3 times. My 3 times 3 is 9. And so there is your final answer. Okay? All right. Cursor down. So Garrett, I just showed you an example with 2 and 2, not 3 and 1 or 1 and 3. All right, yeah. By the way, let me make this comment. Let me go to green. When I went from 4 terms here in these circle, I know this is kind of a mess, these circled terms over here, and I changed it here to 2 terms, this z minus 4 here and z minus 4 here, if that doesn't happen, something's wrong. Okay, you have to be able to have that in common to be able to make all these terms turn into one term. That's what my final answer is one term with only factors, and every factor is completely factored. By the way, I suspect somebody down here on this z squared plus 9 is going to say, oh, I think that's z plus 3, the quantity squared. And if you do that, I have to mark you completely wrong because you don't know that that is prime, and it is prime. Okay, so you better know that the sum of sum of two squares does not factor, it's prime. Okay, let me make sure that I've done everybody's questions. We're almost out of time. Gianna, I did yours. Taylor, I answered your question. Okay, Taylor, number 24 on the quiz. Have we done that one yet? Nope. Okay, this is going to be my last question. All right, let me switch to pretty purple. All right, quiz number 24. So it has 1 cube root of 3 over 16. I'm going to split that up into the cube root of 3 over the cube root of 16, but instead of leaving the 16 as is, I'm going to write it as 2 to the 4th power. Okay, you also could have said 4 squared. Okay, I'm going to leave it as 2 to the 4th power though. So I'm trying to ask myself, what kind of cube root can I multiply this by so that I'll get a perfect cube over here when I multiply these two together? So I have a 2 to the 4th. Wouldn't 2 to the 6th be a perfect cube? So that means I need to multiply by 2 squared. So now I'll have 2 to the 6th over here. Let's go ahead and finish that denominator. The cube root of 2 to the 6th is 2 squared, which happens to be the number 4. Okay, and then up here, because I multiplied that denominator by the cube root of 2 squared, I have to do the same thing to the numerator, and isn't that the same thing as the cube root of 4? So now I'm going to multiply those 2 cube roots together, and I get the cube root of 12. And so my final answer is the cube root of 12 all over 4. We just rationalized that denominator. And that was number 24. Okay. Okay. I know I said I'm trying to see what Sarah's question was. 6/5. Am I looking at the wrong problem? Number 24 was not that. Okay, Sarah, I'm not sure which one you're referring to. Okay, but Dominic and Garrett are asking for the A plus BI thing. All right, I'm going to be honest, I have no idea how picky McKee or Dunkel are about A plus BI forms. So my students, you know I am picky. A is the real part of a complex number. BI is the imaginary part of a complex number. Okay, sometimes your A is 0 and you just have the BI. So I'm just going to make things up. Say I have 2 minus 3i all over 10. Perhaps in Dunkel or McKee's class, that might be fine for you to answer. In my class, I want you to write it in A plus BI form. Okay, so it's not supposed to be a minus. It can be plus or minus actually. Okay, so the A is the real part. Well, that will be 2/10. And then I happen to have a minus sign, so I'm going to put that. And then my B is the coefficient of I. So in this case, that would be 3/10. And then I'm going to write the I. Now this 2/10 simplifies. I always want you to simplify fractions, so it'd be 1/5 minus 3/10 doesn't simplify, and then my I. That is in A plus BI form. Okay, so I'm going to warn you with this last example that sometimes you might have something like, let's say, 3I over -5. And the directions might say, write your answer in standard form, or they might also say, write it in A plus BI form. So I see some crazy stuff where people will go, oh, is it -3/5 plus I? Because they're trying to get an A plus a BI. Well, look at this expression that I wrote. This is completely wrong. Look at the expression that I wrote. Isn't it just one term? Those are factors. That means your A is 0. And so to write this in A plus BI form, I'm not going to write anything for the A because it's 0. My B is -3/5, and then that is times I. So this is how I want you to write it. There's no A, it is 0, and you don't need to write 0 minus 3/5 I. But don't you dare make that -3/5 act as if it's the A, because it is not. It's the coefficient of I. That means it's your B. It's your coefficient of I, the imaginary part. Okay, I hope that helped. There you go. We are done, and we're out of time, and I'm super tired, and I still have tests to grade. So I'm going to stop right there. I hope that was helpful, and I hope you guys go into tomorrow confident with your factoring, because you have got to be good factorers to do well on tomorrow's test. So keep studying, and I will see you tomorrow. All right, good night.